Good morning, guys. So welcome back to Digital Overmorrow, and today I'm going to start with algorithms and flowchart, as I promised in my last video. So from today we are basically entering into our mainstream programming. So okay, thanks for watching our video. Let's start. Let us first start with our what is flowchart. Write down flow chart. Well, a flowchart is a pictorial representation of algorithm. Now, what is an algorithm? An algorithm is a set of instructions which, when given to the input, can process the output. Now you'll ask, that is algorithm is a real programming that we're going to learn in later classes. So, well, algorithm is a kind of programming, obviously, but algorithm can be said as some well-defined programming. Like, if we write the algorithm in C code, like we're gonna solve some algorithms in this class, obviously. So if I write those algorithms in my computer, then it won't run. But algorithms are for the people who doesn't know coding, and if they want to know that how the code is working, then if they read the algorithm of the code, then they can understand that how the code is running. That is what we call an algorithm. An algorithm consists of a set of instructions which, when executed, processes the input into output. And this algorithm may consist of normal natural language in order to make us understand that how the code is running. That is an algorithm. So let's start with flowchart. What is a flowchart? As I told, that it is a pictorial representation of an algorithm. Means when a code is running, like I want to make my computer to print India, to print welcome world, or like that. Like if I want my computer to print hello world, that's better, hello world. Okay, so what it will do that if this is my computer screen, it will print hello world. That's the whole code. I want to make my computer print this. This is to be printed, right? So if I write this code, then I am a coder, you are a coder, you will understand, I will understand, but who is not a coder? And or the code, if the code is a huge code, this is a very small code that I showed now, though. So there are codes which are which are lengthy codes. So reading each and every code lines is a tough one, right? So this flowchart thing, it helps us to understand how the code is working, or how the code actually looks like, right? Now I told that flowchart is a pictorial representation. What does that mean? A flowchart will consist of some pictorial diagrams, some diagrams, and each of the diagrams have different functions that I will tell you now, and those functions will implement those works that the code is doing. Okay, so first diagram, let's start with diagrams. First diagram, that is this one. This we call as a ellipse. What is the function of this ellipse? The function of this thing is start or stop. It will start the flowchart, then it will, at the end, it will stop the flowchart. This thing. What's next? Next is this one, a parallelogram. It gives input and output. Like, I can use this diagram in both functions, during input or output, right? Number 3. This one. That's a rectangle. It is the process box. Like, it will do calculations. Like, if I want my computer to do the sum of two numbers, then when the computer will perform this a plus b, or let me say 1 plus 2, this addition function will be done inside this rectangle box, or process box as we say. Calculation, right? Number 4 is a rhombus, right? It's a rhombus. It is a decision box. Decision box, right? What's the function of this one? It will perform the task of making decisions. Like, what kind of decisions? Decisions like, if I want my computer that I will give a number, and the computer has to say whether the number is even or odd, right? So the computer must check that whether the number is even or odd, then he will tell me, right? Then it will tell me that the number is even or the number is odd. So the computer has to make a decision, right? That this number that I've given 2 as an input, the computer will check that the number is even. Obviously 2 is an even number, so the computer will check that the number is even. So this computer makes a decision that the number is even, so I have to print that the number is even. That decision making thing is done inside this box, this rhombus. That's what we call a decision box. Fifth is nothing. We call it a flow line. These lines connect these boxes with each other. Like, as we say, like, datas flow through these lines from one box to another. So that's it. What was the main thing is, these 5 things are the backbone of flowchart regarding algorithms. These things will help us to make a pictorial representation of any code in C or Java, in Python, or any kind of stuff. This flowchart will help us to make the pictorial representation in order to make us understand the code thoroughly, right? So let's take an example then. Then it will be understandable more. Right. So let's take an example. Right. Like as I say, sum of the two numbers. That will be good. Sum of two numbers. Let's execute this. Well, it's a very easy one, and well, you know, it's nothing to be scared of. What is a programming and like the stuff, like this is the most easiest stuff and the most interesting thing that I have ever learned in programming, and it's very when you make it, it's kind of diagrams and all kind of stuff. So very interesting, right? Okay, so let's start with this. Sum of two numbers. From the first paper, what was this? This is the start or stop button, right? Or box, as you say. So let's start the program then. Let's start the program. This is the thing, the start button. Start. And what was the last thing? I told this as the flow line. It connects all the boxes together, right? So I have to connect this box with the rest of the boxes that I will draw, right? So first draw the flow line. This is the flow line. Okay. So now if I think stepwise, how should the computer perform during while doing this work of sum of two numbers? How will this perform? This will perform like, first I will enter two numbers. The computer will show some text like enter the first number. I'll enter 1. Then it will say enter the second number. I will say 2. Then what it will do, when I will press enter after giving the second number, the computer will take these two inputs into its process box, and in its process box it will perform this thing, and then it will give me as output. First this thing will go inside the input box, right? I have given these two things in input inside the input box. Then the computer will take it to its process box where it will do its process. It will take inside its process box, it will perform the addition, and then it will print as output. And then the program will obviously end because I have nothing to do else. Right? So this is the stuff. I have given the start button. So what will be next? Next will be, of course, obviously the input box. As I told from the last paper, like input box is a parallelogram. So I'll draw a parallelogram obviously. So here it is. Well, it's not a perfect parallelogram obviously because the line is it's a parallelogram, you know. So I have to give it some input obviously. So now if I have to give it some number, so now if I like give it 1 or 2 as input, the computer will perform only the addition of 1 and 2. But then if I want to make the addition of 5 and 6, then it won't perform that, right? It won't perform the addition of 5 and 6 because I've already given it 1 and 2 inside its input box, and then it is processing only the addition of 1 and 2. 1 plus 2, that is 3, and it is giving the output as 3. So that's the main problem, right? So what the thing is that I have to vary my input, right? Like what I have given in my input, it can be 5, it can be 6, it can be 7, it can be 100, it can be 1 million, any kind of input, right? The computer, I don't want to make the addition of 1 and 2. It's an easy one. I want to make an addition of 1 million plus 2 million, 2,009,999. That's kind of addition. So the basic thing is that I have to vary my input. I have to input such a thing that where the input data can vary. So how can I vary an input? Obviously by inputting a variable. Obviously here I have to perform the addition of two numbers, so I have to give two variables, right? So I have to give two variables, that is input, let it be x or y. I have given two variables as input. What next? Next thing is, obviously, as I told here, it will be the process box, because the input stuff is done. I have inputted two variables x and y, right? And then it will perform the addition box, like as we call as process box. The process box will perform x plus y, like the addition performance. That's what I want my computer to do, right? Like x and input x and y, I have given the two numbers and it will perform the addition of x and y. X can be 100, x can be 200, x can be 299, or any kind of number, because this is a variable, right? It's not a constant. So I have drawn the process box. So the main stuff is done, where the computer will perform the addition. So up to this, what I have done, I have given two inputs and then I have performed the addition. So what's left? So I will say the main thing is left is to print the output. So now if I analyze this flowchart, input is done, right? And the processed output is also prepared. Now the thing that is left with, that is to serve us the output. So how the serve should be done? The serve should be done like the addition of two numbers is this. Like the computer will show us what is the result after adding of two numbers. So as we saw here, output box is also a parallelogram. So now two things can be done, right? We can write the output box as like output equals x plus y, or what we can do, we have to obviously write print output equals x and y, x plus y. We can write this, or what we can do, we can take a third variable here in this process box, like say s equals x plus y. What does that mean? I am taking a third variable, that is s, in which the value that is coming after adding of these two variables will store. Like if I give the value of 1 and 2, like 1 is for x and 2 is for y, the result is obviously 3. Then the 3 will be stored in this s variable. That's why s is equal to x plus y. So what we can write simply as print s. Either we can do this thing is also correct. This one is also correct. And this thing is also correct. We can do this or we can do this. Right. So I am taking this whole thing inside the output box. So I hope you guys understand that. What's the difference between two? Here we are taking a third variable. Here we are directly printing this whole stuff. So what next? Our job is done. The addition of two numbers is done. Addition is done. Printing is done. I have got the result. What's next? I have to stop the flowchart. I have to simply stop the flowchart. Stopped. That's how it looks like. Sum of two numbers. Then this is the flowchart of this program. So now let us take another example of the decision taking box. Let's see. So the thing is decision taking box, like I'm showing an example of that. These things are pretty easy, you know. If you give time to this subject, you'll see that it's the most interesting and the most easiest subject ever has born, like regarding this simple problems, right? So example of decision box, right? If I want to make the computer to print India 5 times, so how should the code work? Like how should we prepare the code? First method, like let me write the question. Print India 5 times. That's the code. So what can be done to execute this thing? First process, print India, print India up to 5 times. This is the first process that we can do. It's a correct one. Obviously it's a correct one. Now if I want you to make print India 1 million times, what will you do? You'll do like print India up to 1 million times. That's not possible, right? I can't write a code of million lines for just this simple task of printing India 5 times. So now we have to do it in some different way. We can use it in a decision box, or whether in this way, you know. So let's start this code. Let's do it. So Let us start. As I told that the start button will look like an ellipse. That is start. Okay. So now next is the flow line, obviously. So what I have to do, I have to print India 5 times. Right. So let me write it like I want to make India run in whatever times I want, whether it's a 5, whether it's 1 million, or whether it's 100. That doesn't matter. I want to make the computer do that with whatever number I will give it to it. Alright? So obviously, as I told, like the number is varying, right, from 5 to 1 million to 100. So obviously we have to take a variable. Let's input a variable. Read n. That's the main thing. Read n. N can be 5, n can be 100, n can be anything. Alright. Next is another flow line. Next flow line is the decision box. Now what the thing? Let me give the example with 5 only. Like n is equal to 5. Like I have to print India for 5 times, so read n equals to 5. Like that. Okay. So now the decision box comes into play. How? First time it will print India. For example, India. N equals, if I assume n equals 0, or let me say n equals 1. Again India, n equals 2. Again India, n equals 3. Again India, n equals 4. Again India, when n equals 5. 1, 2, 3, 4, 5. 5 times India is printed. So what's this things all about? Let me say n is a number, right? And I have to, like, n is a constant actually. N is the maximum number of India should be printed, that India should be printed. Like I have to print India 5 times. So the maximum number of India that can be printed by the computer is 5. Is obviously 5. The maximum number of India that should be printed by our computer. So what we have to do? First I have to print India. And obviously read n equals 5. It's an integer, and I have missed a box actually, above this. I had to initialize what this n was, and another variable that was a count. Like, let me do it in a fresh way. I have to take the start button, start. Next it will be input box. or the initialization box. Like for initializing any number, like I want to give the number as 0, I want to initialize n as 0 or 1 or any kind of stuff, right? Like 10, like, so I have to initialize that variable with a constant. So with this n, I should give some value, right? Like whether the value of n should be 1, whether the value of n should be 5. So I have given, because this is an input box, right? So I have to initialize first that what is an n or what is a count. Or we can do this stuff in the decision box also. Like the computable one will read the value of n, then the value of another variable that I was talking about, that is, let me see, as 5 and 0. Why this is 0 I will tell you, and this is 5 because the maximum number of times that it should be printed, that is 5. This n is denoting the maximum number of India that should be printed, that is 5, and the C is denoting the number of times India is printed till now. So let me take it like this, let me say read n equals 5 and C equals, let's say 1, or let me say 0, actually 0. Why it is 0 I will tell you. This is a parallelogram, obviously, for an input box. Next, what it will do, it will check, and the checking is done in a decision box. What it will check? It will check whether this C is less than equals to n or not. Actually, I should have said whether it's less than n or not. Now, I know it's very confusing right now. So, what's this thing actually doing? This C, as I have told, it's telling the number of each time India is printed. Like if India is printed 1 time, it will say that India is printed 1, then 2, then 3, then 4, the job is done. Now why I have initialized this C with 0? Right? Because, and why this is less than n or not equals to why not equals to less than equals to n. So I could have written like C less than equals to n, right? But I have written C less than n, and I have initialized this thing with 0. Why? The first number when it will check, when it will print India, it will be when C is equals to 0. India is printed. C is equals to 1 when India is printed. C equals to 2, C equals to 3, 4 times India is printed. Then C equals to 4, 5 times India is printed. Then if it will go to C equals to 5, and if India also prints when C equals to 5, then it will be 6 times India is printed. Right? That was not my code. I had to print India 5 times. I have initialized C with 0. So I have to end the C with 4, and 4 is obviously less than 5. So up to this, India will be printed, and if it will be 5, then 5 is equals to 5, the loop or this loop will be terminated. That's why I have written C less than equals to N. Now let me draw the flowchart first. This is a decision box. Here's a decision box, and then now we have to remember that all this kind of printing, showing, displaying, all these kind of things are done inside this parallelogram box or the input-output box. Input and output both are performed by this parallelogram thing. Print India, then another thing is to be done, that is C equals C plus 1 then, as I have told, the alias box, that is the stop box, and nothing. So what is this thing? This C, as I've told, it will increment as when India is printed each times, right? So what is this flowchart actually doing? Firstly, C is equals to 0, as I have initialized. It goes inside the loop, and this thing, this whole square thing that you can see I have joined, right? So this square thing is designed for this loop. Like, this thing will be performed as many times I have initialized. Like, this is 5 times. This thing will be performed 5 times, because so that's why it is a loop. What is a loop actually? A loop is any closed figure, as we know. So what is a closed figure? Let me do some geometry here. So a closed figure is like, let me first consider a point. This is a point. So if I move this point like this, then like this, then like this, then like this, so the point is traveling this whole distance and coming back to its final distance, final position. So initial position equals to the final position, and I am doing this thing again and again, like I am drawing this rectangle again and again. So the point is traveling its final or initial point again and again. So this point P is happening multiple times. This point is traveling its initial point multiple times. This is a loop. This is what we call a loop, right? So here what is a loop doing? The same thing. It will print India, again it will go to the loop and print and go to the initial position, that is again print India, again it will cross the loop and it will again go to the initial point, that is again print India. In this way, India is printed multiple times. So let me dry run this code. Firstly, C was 0. it enters into the loop. I have created this loop, right? So it is first checking in the decision box that whether C is less than n or not. 0 is obviously less than n, where n equals 5. N equals 5. So obviously 0 is less than n. So it enters the decision box. It enters, it executes this thing. Condition satisfied. It goes inside, prints India as output. Then what happens? This is the main thing. This is the thing that is making the loop to run. The loop is running. India is printing only because of this function. What is happening? C is incrementing. First time when India was printed, C is 0. Then again India will again print when C is equals to 1. So I have to increment this C value by 1, right? That's what it is doing. C will be 0 equals to 1. 0 plus 1, sorry. 0 plus 1 and the value is 1 and 1 will be stored inside C. This function what happens, right? Let me do this. C is equals to C plus 1. Firstly, C was 0. India was printed. Then it goes down here and this thing happens. C will be 0 plus 1. The first value of C plus 1. The first value of C plus 1, that is equals to 1, and 1 will be stored inside C. And then it will go again back right here. It will again check is 1 is less than n, like is 1 is less than 5. Obviously 1 is less than 5. So condition satisfied. It goes down. Again prints India for the second time. Again C is equals to 1 plus 1. So what value will be stored inside C? That is 2. 2 will be stored inside C. Again it goes back. It goes back and again checks is 2 is less than n. It says that yes, 2 is less than 5 obviously. Condition again satisfied. Again prints India. Again goes down. 2 plus 1 3. 3 will be stored inside C. Again goes up. Again checks. 3 is less than 5. Prints India. Increments. Again goes up. Increments and becomes 4. Again goes up. 4 is less than 5. Again prints India. Then 4 plus 1 equals 5. 4 increments to 5. Goes up. Is 5 less than 5? No. 5 is not less than 5. Loop breaks. Stop. That's it. How many times I have printed? 0, 1, 2, 3, 4. When it is 5, the loop breaks and the code terminates. That's what it was. Printing India 5 times. I have discussed the function of a loop, how does it work and all. So let me just end here the part of this flowchart. I'll go to algorithm, which is very easy, just similar to this. Just I have to write some codes, right? So let me tell you before moving into next topic. Any process like addition, multiplication, modulo, any kind of stuff like these kind of stuff like calculation kind of thing, all are done within this rectangle box. Input output within this parallelogram box. Decision making in this rhombus box. And loop is done by drawing something like this. Okay, I hope things are clear. So let us move on to algorithms. So I've told what is an algorithm previously. It's actually the code, obviously, but it is written in such a manner so that we could understand. It is written in giving some special English language, or in some natural language in the process way, so that we can understand by reading this code directly. Because if I want to read a code of 1,000 lines, I can't check each and every line of a code because it's very confusing, right? So algorithms give us a clear view that what the code is actually doing. Okay? So how it is written? It is the writings, the algorithms are written in such a manner. It is very similar to a cooking recipe book. Step 1, step 2, step 3, step 4, and up to last. Like this, it is written like this. Right? So let's first start with algorithm finding a sum of two numbers. Sum of two numbers. Now, two things that is mandatory for every algorithm, that is start and stop, like a flowchart. Obviously, it also has a start and stop button, or a start and stop step. It is written in steps. So, sum of two numbers. Step 1. What is the step 1? It is actually written like this. Step 1, colon. What is the step 1? Step 1 is start. Like a flowchart. Similarly, like a flowchart. Step 1 is start. Step 2. So, what was the flowchart doing while adding of two numbers? It was firstly taking input of x and y. Similarly, we have to do this. Step 2, we have to write like read x and y as integers. Integers means that x and y should be numbers like 1, 2, 3 up to million, up to infinite actually. So x and y should be integer, else how can I sum of two characters? If I input x and y as characters, then computer can't do the sum of characters, right? So I have to initialize that, read x and y as integers. Okay, what's the next step? Step 3, that is, I have to take another variable. Previously I took a variable like s is equals to x plus y. So I have to take another variable like s. It's the most easiest method. Step 3, set s x plus y. So now, in case of algorithms, this thing is put inside s by using this mark. Here we don't write equals to. If I want to put any value into any variable, we have to use this kind of this sign, this arrow sign. So x and y is obviously put inside this s. What is the step 4? Nothing. The sum is done, input is done. So what we are left with? we are left with obviously displaying the sum, either else how would I see that was the result. So display sum, or you can write print sum, anything. Alright, the code is done. Input is done, process is done, display is done. Input, process, output is done. What we are left with? The last thing, that is stop. This is an algorithm. This is an algorithm of the sum of two numbers. Now, what should we next do? Like, let's print like, yeah, let's do like print India 5 times. Let's do this algorithm. Pretty easy one. Print India 5 times. Alright. What should be the step 1? Start. Now, what should be my step 2? Step 2 should be something that holds the value of 5. Alright? So we can do this like set n equals 5 and c equals 0, like we did in the flowchart. Like I am actually drawing the algorithm of this flowchart, like how the algorithm should look like of this flowchart that I have drawn. So I did this. I have n is equal to 5, c is equals to 0. I have set the value of c and n. Step 3. What was my step 3? Step 3 inside this loop was this: checking whether c is less than n or not. Right? I have to do this. If c is less than n, go to step 4. What is step 4? Print India right? If c is less than n, go to step 4. Like first it will check whether this thing is less than n or not. If it is less than n, it will go to step 4. It will go inside this loop. Like the loop is running, right? So like I have initialized a loop, then I have to run it again. Okay? So next. So India is printed. So what was my previous thing? In this flowchart, I had to increment the value of c in order to draw this loop, right? I have to increment the value of c, right? So now here we did something, a step error. Like, what is a step error? A step error means I have like when a code works, it works step by step, right? So if any step is misplaced, like if the step had to be in the 3rd position, I have mistakenly written that step in the 5th position, so the code won't run in the proper way, right? So I have to write the code in such a way, step by step, so that the code will run in a proper way, like the way I want, right? So here is a step error. I don't know if any of you guys have identified step error or not, because but there is a step error. What is a step error? The step error is that when C is equals to 0, India should be printed. Then C should be incremented. Then the loop should be going, right? Firstly, when C is equal to 0, India should be printed. Then C should be incremented. Then the loop should again go back position. So what is the step error here? Step error is this line. Print India. If I take this as step 3 and if I cut this step, what will we do? Like, what will the computer will do? N is equal to 5, C is equal to 0, India is printed. Then if I do like this, step 4 is C is equals to C plus 1. It means that like we can do like here the equal to sign won't work, so I have to give the arrow sign, right? So C is equals to C plus 1. C is incremented. Step 5, if C less than N, go to step 3. This was the step error. This line should be written and step 5. So let me dry run the code, and obviously the code will end like step 6, that is stop. So here's the end of this algorithm. So let me dry run this algorithm, what it's doing. So it is checking like this. Firstly, start. I have set N value equals to 5, C value equals to 0. Done. Step 3, print India. When C was equals to 0, India is printed. Then I have incremented C is equal to 0 plus 1. Means I have told previously that this value goes inside this C. The C is incremented by this value. 0 equals 0 plus 1 and all. So 0 plus 1 equals to 1. 1 is put inside this C value. If C is not less than N, go to step 3. C is equals to 1 now because I have incremented the value by 1. So C is obviously less than N. Go to step 3. It again return to step 3. Step 3 means print India. India is second time printed. C is equals to 1. 1 plus 1, 2. C is again incremented. Again it goes to step 5. C is less than N. Go to step 3. Obviously 2 is less than N. 2 is less than 5. It again goes back to step 3. India printed. Incremented again. Again it checks 3 is less than 5, obviously go to step 3 again. Print India, India is printed. 3 plus 1 again incremented, it again incremented to 4, 4 is less than 5, obviously go to step 3 again. India is again printed, India is printed 5 times. When C was 0, when C was 1, when C was 2, when C was 3, and when C is 4. And then 4 plus 1 again incremented to 5. Is 5 less than n? Like, is 5 less than 5? No. So this thing won't work. The code will end. This is how the looping works in an algorithm. I hope the things are much more clear now. We will again discuss about algorithms and flowcharts, obviously. Like, from next day class we will start what is coding. Like, I won't start coding directly. I will first make you know that what are the syntaxes are, what are the things are, and then from next to next class we'll start with main coding. And what I will do, I will write a code, like for the simple ones obviously. I will write a code, I will write the code, and on the right hand side I will write its flowchart and its suitable algorithm. So by that way the things will be more clear. Okay, so then we will move on to higher codes. We'll move on to linked list, queue, stack. Well, those are high stuff. Like, first we should know, we should be familiar with what are the basics are. So that's it for today. So it's a very big video, I think. So, well, videos will be bigger from next time. Okay, so okay, please like, share and subscribe our channel, and if you like our video obviously. So thanks for watching, thanks for helping us to increase our views, and thanks for watching Digital Overmorrow. Okay, that's it for today.